to come on stage and get ready for some questions. But first, let's give them all another hand for really brilliant talks. Okay, so we have time for questions. There are mics there, but I can't see, so someone... I'll step up front, okay. Yes, Nicholas.
So, hi. Question for Nils and for Eva. It's about, have you faced cultural issues with the data? And I will subdivide that in data sovereignty, which is not the same as residency. And also, I don't know, when you are capturing data on indigenous land, wherever it is. I mean, you are indigenous, 15th generation. So is the, let's say, Western approach to science being challenged by any community anywhere in the world that you have used either your method or Pegasus in recent times?
Nils, do you want to go first?
Yeah, either way, yeah.
Indigenous.
Well, very nice. Thank you, great question. I think the one is we try to stay out of the legal kind of concept of boundaries, what it is when we detect them, and we always try to stay as neutral as we can in terms of creating data ourselves and then openly giving access to the end user. So we always kind of, from the beginning, thought we didn't want to get partners' data to train, because then you deal with this whole, of course, data privacy issue and everything else. And from our experience, when we work in smallholder markets, there's, you know, in Europe and the US, we have public cadastral data and it's available and it's, you know, it's there. But like once we start working in Africa and different places, like there's very little public data or digital footprint. So I think we have more positive, at least, responses than negative, put it that way. But we don't say that this is the truth either, right? We say this is a supplementary data set that you can use for a very specific use case, which is just identifying planted and non-planted hectares and then building on top of it. So if that answers some of it, yeah.
Yeah, so I guess, thank you for your question, because we have different types of data that we deal with. So some of it is just performance data for the workflow management system that, you know, likely doesn't have at least cultural issues. It does have sensitivity issues because we collect data with people's knowledge of their running Pegasus. They can opt in to send us the performance information. And so obviously we need to deal with the privacy of the data as well when we're trying to share results. But the applications themselves deal with a lot of sensitivity issues, like the astronomy applications use data that comes from telescopes that can be on indigenous land, and they need to negotiate with the indigenous people about the possibility of building research infrastructure that will collect the data, so there's that sensitivity. Also, there is some sensitivity in terms of data. For example, in LIGO, they collect the instruments are very sensitive, and they have thousands of different types of sensors installed in the instrument itself. Some of them, most of them are used to make sure that they're used to clean the gravitational wave signal. Some of them are like seismometers. They can detect things that might be sensitive. For example, some of the installations in India do not report over seismic data beyond the gravitational wave physics physicists. So we have these type of sensitivities, but we don't deal so much with cultural sensitivities that you described. Is it, well,
Don't open the Pandora box.
Yeah, it's hard to, I mean, that's a hard, I mean, we have to deal with a number of different sensitivities when we talk about data, especially now if we're putting that data into AI models and it gets, you know, clobbered with everything else. So that, I think, is a big issue.
Because once once you put it there,
Yeah, you can't take it out, yeah.
yeah. And a follow-up comment, what about Airbus, Planet, all those guys which you subsidize with your work? So, I mean, is that, anyway, I just want to be a little bit controversial. So, how do you sell, resell, operate? I mean, you're a middleman at the end of the day, but where is the sovereignty? Where is, anyway, convince me how everything.
Any? Yeah.
No, I don't know if you wanted me to answer it, Nicholas,
Oh,
but,
please, go
or
ahead.
not.
No, please.
But yeah, no, I think there's space for all of us, like in, at least when I think of satellite imagery data, and we're just adding on top of what, European Commission and EU tax money's spent building this wonderful data set that should be used to its full extent. And I mean, it's still true that about 80 or 85% of all commercial grade satellite data revenue from Airbus Planet is still military and defense, right? So, I mean, it just goes to show that it's agriculture, environmental monitoring doesn't have the budget that the rest of, that kind of entities have. So I think there's still space there.
Any other questions? Maybe I'll step back a little bit, right? So we've seen great examples of how you've taken AI and more traditional modeling technologies and computer science concepts and had very broad impact on a range of applications, right? That inherently requires multidisciplinary collaborations. How have you done that so well?
Walk a mile in their shoes. There is no easy way to do it. You have to spend time understanding the domain, and even more importantly, spending time getting to build trust with the domain scientists. So that's the two ways you can do it, and in fact, it's one way. You build trust by working with them, trying to understand what they want. One of the things I learned early on is that if I took an approach where a scientist just came to me and said, I want this, that was never the right answer for what they really needed, because they would perceive what I could do for them based on popular literature, etc., as opposed to what I really could do for them. So spending a few days talking to them, trying to solve some of the easier problems, that's where you start building both the trust and the understanding of what is it they really need. So that's been a thing for me, but of course it takes time. The old joke, the first grant you get to know each other, second grant you do something, third grant you fight.
Nice way to quantify it. Any other thoughts?
Yeah, so I agree with you, Abani, absolutely. I think the other part is that sometimes things don't work out. And so you have to be prepared for that, and that's the nature of the work, that some things work and some things don't, and you just try again or try different partnerships. But you have to be flexible and open to that. And also, like you mentioned, time, you need time, so you don't expect results right away. It takes a while to develop these relationships with trust. So patience, I think, is the most important here.
Yeah, I echo with the collaboration aspects. It's always a teamwork between domain scientists and the modeler or computer scientists that we develop our engine or models. I think one thing that I can share from our experience in the past 3 years working on causal AI engine, we were working a number of different domain scientists to understand their data. Things didn't work out the way we were expecting, but it worked out for a different domain because we didn't have the extensive data or the way we were thinking to apply our model. So it's a two-way lane. Sometimes we don't have the good understanding of the data and the knowledge, the domain that we are applying our tools, but at the same time, sometimes we have the data and knowledge, but we don't know how to really tailor our tools in that direction. So it requires partnership over the period, in order to solve complex problem.
I can only echo what's being said here. I think when we started, I remember thinking that it would be easy, like to do this stuff. And then, 5 years later, I'm realizing every day how difficult it is. And it's not linear, I guess, right? Like you're not like, it's up and down. And then you just got to have so much patience and understanding how complex the problem is to be able to progress, I guess, somehow. But yeah, I agree with everyone else.
Maybe a final question. So in multidisciplinary translational research, you're often trying to combine what problem to solve and how to solve it, right, and closing the loop there. With AI and the power of AI, right, in addition to what problem and how, you also have to ask the question, should I do this? How do you grapple with that?
Well, just do it. And if it blows up in your face, you shouldn't have done it. No, I'm kidding. There's two aspects to the should I. The commonly perceived aspect is somehow it's dangerous. The other aspect that I actually see more often in my work is people ask you to automate things that it just doesn't pay off. A couple of hours of graduate student time is still better than 3 months of AI training. So what should be automated are things that are not in the quote-unquote affordable human comprehension and execution abilities. So to me, that's because the AI perception has run a little bit ahead right now, I think one has to be careful about what is it AI should be used for, where does it make a difference. So in problem I showed you with the combustion, understanding the flame properties is very complicated. Human comprehension runs very far behind because it really needs a huge table lookup in a very simple way of thinking about it. AI, perfect for that. Some others where grad students are smarter, keep them.
Yeah, I guess there are also cases where just a simple statistics will help you. That's enough, right? And so you don't need to throw in a huge machinery that can be very expensive in terms of resources and time. So yeah, just be diligent in looking at when it's appropriate to use it and when not.
Excellent. Looks like we're at time, so another round of applause, and thank you for being here.